Hello, smart learners. You're welcome back to this class, Mass Mind with Ijoma. I hope you've been finding other classes very helpful. Don't always forget to like, share, subscribe, share this channel to your friends. Tell them about us and always join us in our classes. Have you thought about the reason why we can get the square root of 16, 25, 36, but we can't actually get the square root of 10 or square root of 24 and the rest of them? That is because we have perfect squares and non-perfect squares. And numbers that have exact square root are perfect squares. Exact square root means numbers that have a whole number that multiplied itself to give it. Like 36 has a whole number, which when you multiply by itself, it will give it 36, and that is 6, right? 5 have a whole number that if you multiply by itself, it will give you 25. That's 5 is the square root of 25. Numbers like 100, we have the square root as 10. But when you come to numbers like 20, numbers like 24, numbers like 72, it does not have an exact square root. Now, those numbers are called irrational numbers. They are called irrational because they don't have an exact square root. And they cannot be expressed as an exact fraction. Okay? Now, that brings us to what we have today. Surds. Those numbers that does not have exact square roots are classified as surds. And there are ways to sort them out. Okay? Now, we have numbers. Let's start with squares and square roots. Squares. Square of a number is the end result you get when you multiply a number by itself. Square of 5 means 5 times 5. That's 25. Then coming to square root. When you talk about square root, it means the number that was multiplied by itself to give that particular number. Example, the square root of 100. What number was multiplied by itself to give you 100? That number is 10. And remember, in one of our classes, we've talked about how to find square roots effectively. So let's talk about square root of 100. You will just divide. 2 can go. Remember, numbers that end in 0, 2, 4, 6, 8. 2 can divide them without remainder. So we have 2, 50, 2, 25, 5, 5, 5, 1. So 2 times 2 and 2, 5 and 5, 2, 5. So 2 times 5 will give us the square root of 100, which is 10. 2 times 5 is 10. Okay? Now, that is that for squares and square roots. Now, perfect squares. Perfect squares are numbers that have an exact square root. Okay? Like I said earlier, when you talk about perfect square, it means that number that a whole number multiply itself to get. Okay? That's a perfect square. And we have our first perfect square is 1. Because 1 times 1 is 1. Next is 4. Because 2 times 2 is 4. Next is 9. 3 times 3 is 9. Next is 16. 4 times 4 is 16. Next is 25. 5 times 5 is 25. Next is 36. 6 times 6 is 36. Next is 49. 7 times 7 is 49. Next is 64. 8 times 8 is 64. Next is 81. 9 times 9 is 81. Then next is 100. We'll stop here because 10 times 10 is 100. These are perfect squares, okay? They are perfect in the sense that a number multiply itself to give them a whole number, particularly, okay? Now, coming to numbers like 20. If you want to get the square root of 20, there is no exact number that you multiply by itself to get 20. So that brings us to surd. Now, in this case, there is a way to simplify. Find the factors of this number. Let's list out their factors. Of 20, we have 1, 2, 4, 5, and 10 and 20. 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. That's how to check if you're correct. You take them end to end. They will give you the product. Okay? Now, as you found the factors, now find a factor of 20, a pair of its factor that has a perfect square. Now, looking at all this pair has a perfect square, 4 and 5. So 20, root 20 is equal to root 4 times root 5. Okay? Now, what is root 4? Square root of 4, which is what? 2 times root 5. Therefore, the result is what? 2 root 5. Always take all these roots as if they are s. Take them as they are s, because it will enable you to know what to do easily. Okay? So, in this case, you just do 2 times root 5, which is what? 2 root 5. We have another number. You can take any other number. We have 48. Now, factors. Let's list out the factors of 48. We have 1. We have 2. Can 3 go in 48? Yes, 3. Can 4 go in 48? Yes, 4. Can 5 go in 48? No. Can 6 go 6 in 48? Yes, it can go. Can 7 go in 48? 7, 7, 7. No. Can 8 go? Yes. 6 times 8 is 48. Now I've gotten the two middle numbers. If you have gotten the two middle numbers, you just be taking the end. 48 divided by 4. That should give us 12. That's the next number. 3 divide 48. 16. 2 divide 48. 24. 1 divide 48. 48. Did you see how I got these remaining ones? After I got 6 times 8 that I know that is equal to 48, I already know is the middle factors. So what do? I'll just be taking the ones I have already to divide to get the pairs of it. Okay? So in the sense that if you go with pairs, 1 times 48 is 48, 2 times 24 is 48, 3 times 16 is 48, 4 times 12 is 48, 6 times 8 is 48. The factors are complete. Now, amongst the factors, what pair has a perfect square? If there are two perfect squares, like we have two perfect squares, you take the pair that has the higher perfect square. Remember, 4 and 12, there is a perfect square 4. But because we have 16 and 3, I shouldn't be taking the lesser perfect square. I should take the bigger or higher perfect square, okay? Now, we have 3 and 16. Root 3 times root 16. Or you say root 16 times root 3. Any of them can come first. Because 2 times 3 and 3 times 2 is the same thing as 6. Okay? Multiplication, you can misplace them the way you want. It will still give you the same end answer or end result. So, let's go. Root 16, square root of 16 is 4. So, this should be 4 root 3. That is 48. Okay? Now, coming to the next. Now, let's talk about addition and subtraction in Surd. When you talk about addition and subtraction in Surd, once the surds are the same, you can add and subtract. Once the surds are different, you cannot add and subtract. Okay? So, if you have things like 3 root 2 plus 5 root 2. In this case, you can add it. Even if it's subtraction, you can still subtract. Why? Because the roots, I told you, treat this root as if they are x or y. Okay? So it's just like saying 3x plus 5x. Okay? So it means adding the 2. 3 plus 5 is 8. 8 root 2. It's as simple as that. That is because they have the same surd. Okay? But in a case where you have things like 3 root 5 plus or minus 2 root 3. In this case, you cannot add or subtract. Okay? Reason being that this is just like saying 3y minus 2x. X and y cannot subtract or add. Do you understand? So that's how it works. Okay? Now coming to multiplication of surds. In multiplication, even if you have 2 times 5, you multiply. If you have x times y, you multiply. Whatsoever you have, you can still multiply. That is for multiplication, okay? So in this case, you just have to multiply straight. You have root 3 times root 2 is just like saying root 3 times 2. Okay? 3 times 2. The answer will be what? Root 6. Just as simple as that. Okay? Coming to this, roots, I've always told you, treat this as your x and y. Okay? So you just multiply your numbers. 2 times 3, 6. Then root 3 times root 2, root 6. So 6 root 6. That's how it works for multiplication. In our next class, we will talk about rationalization of surd. Follow us up, subscribe, and be a part of that class.